Assalamu alaikum class, how are you? Fine? Hope you have learned a lot from the previous lecture. I'm sorry I just forgot a point while winding up my last lecture. The point was that when I was writing the properties of the gravitational force, then I miss one important point, and that important point was the gravitation even affect light. The gravity affect light. When the gravity is strong, then it can even bend light also. Okay, so that was one of the point which I was supposed to tell you, but I forgot. Our today's topic is the gravitational field, right? The gravitational field. Now, what is the gravitational field? You can define gravitational field in many ways. Gravitational field is, in fact, it is the area, it is the space, you may write region, or area around a mass, a massive object where the gravitational force acts. Where the gravitational force acts. That is known as the gravitational field, because we are interested that to which limit the gravitational force of an object can act, because you know gravitational force is the natural property of an object to exert pull on other object. So we just want to know the limit, right? So you see that, look, F for example, let us suppose F, this is an object or a body. Let us suppose, for example, if I just consider it as R, as you see it like this. Now I just want to know that what will be the limit to which it can act a force on the object. Usually that is what the gravity is, in fact, that is the infinite, it exists everywhere, right? Whenever two bodies come closer together, they will exert the gravitational force on each other. It doesn't matter whether if they are far or close, there will be the gravitational force between them. So the gravitational field of an object, the question is that how to denote the gravitational field of an object. We can denote the gravitational field of an object by using the lines, the arrows like this, for example. That is, the gravitational field can be denoted by lines that are drawn radially inward. Right? Radially, that is the gravitational force. It is what? Denoted by what? Denoted by the lines. Denoted by what? Denoted by the lines. Sometimes we call the lines of force. Which are drawn radially inward. Now I will explain what does this mean, the radially inward, right? Look, and why inward? You see that, look, because these are what? These are the gravitational field lines. Since these lines, the gravitational field, in fact, exist all around the massive object. The massive body or object, they exist all around. You see, they will be denoted by these kind of lines which are drawn radially inward. By radially inward, I means that each line makes an angle of 90 degrees with the surface of the object, like this. These are radially inward lines, as you see. Look. These are enough, I think. It could be infinite, we cannot count them. Now, look, this is in fact, the gravitational field lines are one of, in my opinion, the gravitational field lines are in fact the geometrical representation. The geometrical representation of the gravitational force. We can see even it can represents your universal law of gravitation. Now, why directed inward? This is the first question. Directed inward because you know that when I throw this marker up, what happens? It comes back towards the ground. Anything when you throw, even at the fastest speed, for example, even when you fire a bullet, even then the bullet has to come towards the ground. So anything that you throw in the upward direction, they always come towards the ground. Why? Because the gravity is attractive. So this is why the lines are drawn inward. They shows that the force is attractive. Right? Now, another important point that these are the imaginary lines, remember. We cannot make them directly because we cannot see them. Right? And now this gravitational field, even now it has been detected also, but right now in our level here, right now I cannot see. For example, whatever is the gravitational field around me, I don't see. Maybe of the earth I don't see. So this is why these are the imaginary lines, but they help us. How they help us? Now let us see, for example, one important thing. You see that where the lines are closer, the field is stronger. Where the lines are what? Where the lines are closer, the field is stronger. So look, this just points towards the inverse square law part of our previous lecture, right? Where you have seen that the gravitational force inversely proportional to what? It is inversely proportional to r square, like that r d square. So you see that, look, the more you are closer to the massive object, the more will be the gravitational pull on you, right? And this is why, so the more you are closer to the body, the lines are closer together, and the more you away from the body, the lines are spread apart, and the field becomes what? And the field becomes weaker and weaker and weaker. So this is another important point about the gravitational field lines. This field, the gravitational field, is usually the field force. It is what? It is the field force. So if you remember the previous lecture where I told you that this is the kind of force which is non-contact force, which does not require a physical contact between the bodies, which can act at a distance. So field forces are actually those forces which can act at a distance. So those forces are usually called the field forces, right? So the gravitational field is the region or the space around the massive object where the gravitational force can act right? One. Second, the gravitational field lines are actually the imaginary lines which indicates the gravitational field around any mass of objects. And where these lines are closer, the field will be stronger. Where they are far apart, the field will become weaker. And what does this mean? This means, in fact, that the gravitational force decrease with increase in distance. As you move away from the body, the gravitational force decreases. So, hope you have learned a lot about the gravitational field. So, let us move on to the next topic. Our next topic is most probably the gravitational field strength. This is also important. The gravitational field strength. Now, what is the gravitational field strength? How we will know the gravitational field strength of an object or of a mass of body? So, the gravitational field strength physically, it is defined as the gravitational force. It is what? The gravitational force acting, the gravitational force of an object acting, the gravitational force acting per unit mass of an object is called the gravitational field strength. Field strength. Right? This is usually mathematically, we can write that mathematically this can be written as the gravitational force. The gravitational field strength. The gravitational field strength is equal to what? The gravitational force per unit mass of an object. Right? And that is what we can write about the gravitational field strength. So, that is in fact, it is denoted by G, right? And this can be written as that gravitational force. For example, if I just talk about the Earth, then what will be the gravitational force of the Earth on an object? It will be equal to the weight of an object. So this is very simple. What I will be writing like this, this will be equal to W divided by what? M, mass of an object. So this is in fact what? This gravitational field strength is in fact another name for the gravitational acceleration which you have studied in the kinematics chapter. So it is just like that, and this specifies how strong the gravitational force of an object or planet B. So if you have this thing G greater, then what will happen? You have the greater gravitational field strength. For example, look, if you compare the gravitational field strength of the Earth and of the Moon, then definitely it will be greater for the Earth than for the Moon, right? And similarly, if you compare it for the same unit mass for the Sun and the Earth, then definitely it will be far greater for the Sun than the Earth. Now, what would be the SI unit of this? The SI unit of this gravitational field strength is Newton. Why? Because you know weight is measured in, our force is measured in Newton. So it will be Newton per kilogram. Right? And if you just see the nature of this gravitational field strength, this is a vector quantity, remember. It is a vector quantity. So it has a direction. Right? And that direction is always, if you just consider it for the earth, it is always directed towards the center of the earth, right? So there is this direction. Now this, remember class, as far as your exam is concerned, maybe if it comes, this Newton per kilogram is exactly the same as meter per second square. So this gravitational field strength is nothing, but it is just, you may say, a gravitational acceleration, right? They can determine the field strength, and it is the same for all kind of bodies, right? Why? Because they, look, if you increase the mass of an object, what happens? The weight of the object increases, and you have the same thing again. If you have the mass smaller, right? For example, small mass, small weight, and you have g the same. So you see that this g in fact does not depend on the mass of an object. It depends on other parameters, and those other parameters inshallah we will discuss in our next lecture. And but it is most probably it depends on what? It depends on the mass and the radius of the given object or plane, right, of which we are going to determine the gravitational field strength. So this is all about the gravitational field strength of an object. Now you see that this is very important. Just knowing the value of this g, the gravitational field strength, we can determine how strong the gravity is for certain for the certain planets or for the certain object. For example, look at the black hole. This g for the black hole is very large. It is so large that even light cannot escape from it. So the greater this gravitational field strength, then the greater will be the gravitational force of an object. So hope today you have learned about the gravitational field strength. So in our today lecture, you have learned about the gravitational field. Then what is the gravitational field? The gravitational field are in fact it is the region or the space around massive object where the gravitational force acts. They are denoted by the imaginary lines. They are drawn radially inward. Where the lines are closer, the field will be stronger. Where the lines spread apart, the field will be weaker, right? And as the distance from the body increases, then the gravitational force decreases, right? And then there was the gravitational field strength. I told all about the gravitational field strength also. Stop.